If you want to take your projects to the next level, let me show you how I supercharged mine. It blew my mind how easy it was. So back in the day, getting electronics projects up and running was hard. You had to know a lot of electronics theory to get a circuit up and running and working reliably. That was until I discovered Arduino. Arduino is an open source framework, both hardware and software, which enables you to create complex circuits and complex actions relatively simply. So to quote Arduino CC, Arduino is an open source electronics platform based on easy to use hardware and software. Arduino boards are able to read inputs, light on a sensor, finger on a button or a Twitter message, and turn it into an output. Activating a motor, turning on an LED, publishing something online. To demonstrate the differences between classic electronics and Arduino, I'm going to use an LED flasher as an example. In the Classics Electronics project, we're going to use a 555 timer chip, and in the Arduino, we're simply going to use an Arduino, a resistor, and an LED. So for the Classic Electronics LED flasher, we will need an NE555 timer chip, some resistors of varying values. These two are paired up together because I don't have the exact value that I need. By combining these, we actually get close to the value. A 10 microfarad electrolytic capacitor and an LED. So to bring this all together, we need a solderless breadboard and some power. Power in this case is coming from a 5-volt USB charger. We'll start by placing the chip onto the breadboard. Then we have to follow the schematic to build the circuit. We start by orientating the chip with the notch towards the top. That means this top left pin is number 1, 2, 3, 4, 5, 6, 7, and 8. Sometimes there's also a dot marking pin number 1. With the chip in the breadboard and orientated, we're now going to take the power and connect it to pin number 8. Next we connect pin 8 to pin number 4. Next we connect the upper resistor between pins 4 and 7. We then connect the lower resistor between pins 7 and 6. Pins 6 and 2 are then connected together. And then we add the electrolytic capacitor between pin 2 and 1. Then we connect pin 1 to the ground source of the power supply. Last but not least, we then add the resistor and LED. Now, if we've done everything right, we should power this circuit up and this LED should flash. So the flash rate of the LED is a relationship between these two resistor values and the capacitor. Once you've soldered this circuit up, the only way you could tune this is if we were to use two variable resistors or potentiometers to change these values in the circuit. Now let's take a look at how this is achieved using an Arduino. Firstly, we need an Arduino, some resistors, and an LED. We place the Arduino in the breadboard and connect the digital pin to the spare slot on the board. We then add the current limiting resistors and then the LED. Finally, we connect the other side of the LED to ground. Once inside the Arduino IDE, we need to open up an example sketch called Blink. To do this, go to File, Examples, Basic, and Blink. Once inside the code, we're going to make some amendments. First of all, we're going to change the LED built-in option to reflect the pin that we've chosen to drive our LED. In this case, it's pin 12. Then we move down into the loop and change the LED built-in option again to pin 12. The way this program works is that the digital write function sends the pin that we defined high or 5 volts. It then delays for 1000 milliseconds or 1 second, and then writes a low value, taking it back to 0. It then delays for 1000 milliseconds, and it repeats until we choose to power down the Arduino. Next, we need to program the Arduino. To do this, we plug in the USB cable and plug it into the USB port of the computer. Then we click the Upload button, and it programs the board. If we've done everything right, the LED should now be flashing. Unlike the classic electronics project, we can actually change the value of the flashing rate in software. To do this, we just change the value of the delay to another number. Re-upload the code, and it'll reflect the change. Ultimately, that's Arduino Superpower. Once the hardware configuration has been made, you can change the way it behaves in software, making it infinitely flexible. There are many different types of applications that you can use an Arduino for, and there are many different boards that have different capabilities. Here's a quick overview of some of the boards that I've used. First of all, we have the Arduino Uno. The Arduino Uno is almost a credit card size main board with an Atmel 328 processor on board. There's a variety of pins along the side which break out the pins of the chip to make them more easily accessible. Their standard layout also means that there are a variety of third-party hats that you can plug into the Uno, giving it additional functionality, such as Wi-Fi, Bluetooth, Ethernet, and even the options to power motors. The big brother to the Uno is the Arduino Mega. The Arduino Mega has a more capable processor. It has many more pins, meaning it has the ability to drive more complicated projects. For example, this particular board is actually out of a 3D printer. Next up is the Arduino Pro Micro, or Leonardo. So the Leonardo has a distinct advantage in that it can actually be programmed to become a human interface device, meaning that this can be turned into a keyboard, a mouse, a joystick, all natively within the Arduino itself. Its small form factor means that it can be placed into very tight spaces, so version 1 of my Stream Controller was made using an Arduino Pro Micro. So next up is the Wemos D1 Mini. This is a Node MCU board which on board has an ESP8266. This can connect to B, G and N wireless networks and communicate with web pages and other different protocols across the network to achieve some really complex and cool projects. Last and certainly not least is the ESP32. The ESP32 is this module here, and the remainder of this board is the breakouts of the pins and also USB functionality to be able to program and read data from the serial communications. What's different about this particular microprocessor is that in here we actually have 3 processors. 2 high-speed processors, which is more capable than the previous processors we've been talking about, but it also has an ultra-low power CPU as well. So we can build projects which are battery powered and will last a considerable amount of time by comparison to running them on both cores. So as you can see, Arduino is an extremely flexible and powerful solution. It lowers the bar of entry for people trying to get projects up and running and achieve complex actions. If you're already using Arduino, let me know down in the comments what you're using it for and what problems you're solving. And I'll catch you in the next video.